Good day, class. Today we'll be looking at change in momentum and impulse. We want to see how we can relate change in momentum to impulse. Let's look at impulse first. What is impulse? Impulse mathematically is given by I. We use I to denote impulse. It is given by the product of force and time. If I press my hand on this board for 5 seconds and I apply a force of 20 newtons. The force of 20 newtons represents the force applied. For how long? I said 5 seconds. So if we have this, the impulse for this becomes what? 100 newton second. Now, impulse basically talks about the force applied on a body for a given period of time. That is impulse. So mathematically we say it is the product of what? Force and what? Time. Which means generally we can say that I is equal to what? Ft. Where the unit for impulse becomes what? This is for Newton, this is for what? Second. So the unit for impulse is what? Newton second. From basic physics and from Newton's second law of motion, we looked at how we derived F equal to ma from Newton's second law of motion, how we derived F equal to ma, which tells us that force is equal to the product of mass and acceleration. From Newton's second law of motion, where we derived this equation, we stated that the rate of change of momentum is directly proportional to the applied force and takes the direction of the applied force. If we derive that equation briefly again, we have this. We stated that rate of change of momentum is directly proportional to the applied force. We have this change in momentum all over time. So this is a sign of proportionality. This gives us what? Rate of change of momentum is directly proportional to the applied force. So if we have this, it means that we have mv minus what? mu, because change in momentum is equal to what? mv minus what? nu, which is initial final momentum minus what? Initial momentum. That gives us change in momentum, which is what I have here. So all of this over what? Time, because we say the rate of change of momentum. So if we go further, we have that m is directly proportional to what? M into v minus u, close bracket, all over what? T. So this gives us F directly proportional to what? ma, because a is equal to change in velocity over what? Time. So all of this now represents what? A. So we have this. Then, for the remove sign of proportionality, we have a constant k, and k is equal to what? 1. So that gives us our F is equal to what? ma. That is how we arrived at F is equal to ma. Now, from here, if we go back to this equation here, where we already know, if we go there, you know that if we remove sign of proportionality, we have that k as the constant and k is equal to 1. So let us ignore that. So we say F becomes equal to what? mv minus mu all over t. So if we do this, if we cross multiply, we are going to have that ft is equal to what? Change in momentum mv minus what? mu. And remember that we have said from the beginning that impulse I is equal to what? Ft. So generally we can say again that impulse I is equal to what? Change in what? Momentum. So if we look at this, we know now that we can relate change in momentum and still call it what? Impulse, depending on the question, depending on the provided what? Parameters. I came across a question where some parameters were given, where, let's just take some of the parameters that were provided. They gave that F is equal to, let's say, 5 Newton. A force of 5 Newton is applied on a body for 2 seconds. Time provided, 2 seconds. The question now says, find the change in momentum. Find the change in momentum. If you have a question like this, and you do not know that change in momentum can also mean impulse, you'll be looking out for mass provided and velocity provided. because the general thing we know is that momentum is what? Mass times velocity. So for this question, they are actually asking us for what? Impulse I, which is equal to what? Ft, which gives us what? 5 times what? 2, which gives us what? 10 Newton second. So if we have this, it means that we can understand how to relate impulse and interchange impulse for change in momentum. So if we relate this now to change in momentum and conservation law of linear momentum. Conservation law of linear momentum talks about the momentum before collision and the momentum after collision. So if we have momentum before collision and the momentum after collision is the same, we can say that momentum is conserved.